are going to explain the project a deep learning ensemble with data resampling for credit card fraud detection. Introduction. The primary goal of this project is to enhance the detection of credit card fraud. The importance of this project is substantial. By improving credit card fraud detection, it has the potential to reduce financial losses. Additionally, it plays a pivotal role in strengthening financial security in the digital economy. This is critical because as more financial transactions go digital, the risk of fraud increases and trust in these digital systems becomes paramount. Traditional methods of credit card fraud detection have limitations. They often fail to capture the sequential behavior of transactions and struggle with class imbalance, where there are far more legitimate transactions than fraudulent ones. These issues impact their effectiveness. So, to overcome these limitations, the project introduces cutting-edge deep learning techniques. It employs ensemble model strengths and uses the smart ENN approach to address class imbalance and enhance fraud detection's accuracy and robustness. The project's outcomes benefit various stakeholders, including financial institutions, credit card companies, and consumers. It leads to improved security, reducing the risk of financial losses for these entities. Objective. So, the primary aim of this project is to develop a highly efficient credit card fraud detection model. To achieve this, we are combining two key techniques, the smart ENN data sampling method and a deep learning based stacking ensemble approach. One major challenge in credit card fraud detection is the imbalance between genuine and fraudulent transactions, with the latter being a minority. Additionally, people's shopping habits with credit cards change over time. These challenges can confound traditional machine learning methods. So, this project is designed to address these difficulties. Instead of treating credit card fraud detection as a straightforward classification task, we are approaching it as a sequential modeling problem. This means we are looking at the order and sequence of transactions. By doing so, we hope to become more adept at identifying even the subtlest changes in how legitimate card holders spend their money. This, in turn, should significantly improve the accuracy of fraud detection. Requirements needed to execute this project are hardware requirements, operating system of Windows, processor of i5 and above, RAM of 8GB and above, hard disk of 25GB and above. Software requirements needed are Anaconda 3 and Visual Studio Community version. Now we'll discuss the working modules of Law of Work. The first step is importing required packages. In this step, we will import essential libraries such as NumPy and Pandas for data manipulation and analysis, sklearn for machine learning and data pre-processing, Matplotlib and Seaborn for data visualization, TensorFlow Keras for deep learning and neural network modeling. The second step is exploring the dataset. In this step, we import credit card fraud data, employ exploratory data analysis and feature correlation analysis to better understand the dataset. These techniques help reveal data distributions, outliers, and relationships between variables, aiding in subsequent data processing and model building. The third step is visualization using Seaborn and Matplotlib. In this step, we employ Seaborn and Matplotlib to create visual charts and graphs, facilitating a better understanding of dataset characteristics. The next step is data processing. In this step, we clean the dataset by removing duplicates and handling missing values. We also use standard scaling to ensure uniform feature scales for accurate machine learning. The next step is feature selection. In this step, we utilize the select k-based technique. This method involves selecting the top k features from the dataset based on a scoring function. We have used it to identify and retain the most informative features, helping optimize the performance of our machine learning models. The next step is appending selected features to X and target column to Y. The selected features are appended to the X dataset and the target variable, in this case likely fraud versus not fraud, is assigned to the Y dataset. The next step is train and test split. In this step, we segregate the dataset into training and testing subsets. The training subset is used for model learning while the testing subset evaluates the model's performance on new data. The next step is training and building the model. This is a substantial step where various models are constructed and trained to predict credit card fraud. The models include both the original models and those enhanced using the Smart ENN method, which deals with class imbalance. And in the next step, that is extension phase, ensemble models are created by combining predictions from multiple models for improved accuracy. So we employ the preprocessed dataset to train machine learning and deep learning models. These models learn data patterns and relationships. Subsequently, we evaluate model performance on a separate test dataset, employing metrics like accuracy, precision, recall, and F-score to assess their performance in fraud detection. This evaluation step helps ensure the models are accurate and reliable for real-world use. Additionally, a user-friendly Flask-based frontend with authentication was developed. The next step is Flask framework with SQLite for sign-up and sign-in. In this step, we integrate user registration and login functionalities into the Flask framework. Users can sign up by providing their information, and subsequently they can securely log in using their credentials. This enhances system security and allows for personalized user experiences. So after signing in, users provide input through the front-end interface, which include parameters required for fraud attack prediction. Later, the inputted data undergoes data preparation. The preprocessed input is fed into the trained models, and the models make predictions regarding fraud attacks based on the input data. And the results are presented to the user through the front-end interface. Now we'll understand the algorithms used. The first one is AdaBoost. AdaBoost is an ensemble technique that combines multiple weak models to create a strong one. It helps improve classification accuracy and handles class imbalance effectively, which is crucial in credit card fraud detection. The second algorithm used is random forest. Random forest is an ensemble method that aggregates the predictions of multiple decision trees. It reduces overfitting, enhancing the model's ability to make accurate predictions, particularly in scenarios with complex data like credit card transactions. The next one is MLP, that is multi-layer perceptron. MLP is a type of neural network with multiple layers that can learn complex patterns within the data, making it suitable for detecting intricate fraud patterns in credit card transactions. The next algorithm used is LSTM, that is long short-term memory. LSTM is a form of recurrent neural network capable of modeling sequences. It is well suited for detecting fraud that occurs over multiple credit card transactions by capturing sequential dependencies. The next one is GRU. GRU is another recurrent neural network that efficiently handles sequential data. It is suitable for modeling patterns in transaction sequences, contributing to fraud detection. And the next one is combination of LSTM, GRU and MLP. So they together create a comprehensive framework for analyzing sequential data and making predictions, making it powerful for detecting credit card fraud. So this is the horizontal bar graph comparing accuracies of different algorithms. In this graph on x-axis I have accuracy scores, and on y-axis I have algorithm names. So accuracy measures the overall correctness of predictions, showing the percentage of correctly classified instances. This is precision comparison graph. In this graph on x-axis I have precision scores, and on y-axis I have algorithm names. So precision measures the accuracy of positive predictions, indicating how many predicted positives were actually correct. This is recall comparison graph. In this graph on x-axis I have recall scores, and on y-axis I have algorithm names. So recall measures the ability to identify all relevant instances, showing how many actual positives were correctly predicted. And this is F-score comparison graph. In this graph on x-axis I have F-scores, and on y-axis I have algorithm names. So F-score combines precision and recall into a single metric, balancing accuracy and completeness in predictions. And these are comparison graphs for models built using Smart ENN method, which deals with class imbalance. So the algorithm which is best performing will be used for predictions. Execution of the project. To execute this project, first we need to open the code folder which contains the project source code files. So this is static folder. This folder consists of files related to CSS, JavaScript and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc. which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML pages. This is credit card dataset on which we will train the models. These are model files which contain algorithm information. These files will be loaded into the project code during runtime. This is notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. And this is signup.db file. This file is the database file used to store user information. Now copy the path of the code folder from the address bar of the file explorer. I'm copying it. Open Anaconda prompt. Use the command cd followed by space and paste the copied path and hit the enter button. So this command is used to change the current directory to the code folder's path. So now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, localhost and port unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. So here we can see a login link. Click on it. So give the credentials, username and password to login. And if we don't have the account, we can click on this link, sign up link. So here we have to provide these details and click on sign up button to register. So as I already have an account, I'm clicking on this link. So here I have to give my credentials. And click on sign in button. So it has redirected us to the credit card fraud detection page. So before understanding about these features, we'll understand about PCA, that is Principal Component Analysis. It is a technique that reduces the complexity of data by transforming correlated variables into a smaller set of uncorrelated ones. It is used to simplify data while retaining important information. So the dataset originally had various transaction related features like amount, time and V1 to V28. So to protect privacy, these features were transformed using PCA into a smaller set of features including V3, V4, V7, V9, V10, V11, V12, V14, V16, V17 and V18. So details about these original features were kept confidential to safeguard sensitive information. So now we have to fill in all these parameters. So the V3 would be 2.53, V4 would be 1.37, V7 would be 0.23, V9 is 0.36, V10 is 0.09, V11 is minus 0.55, V12 is minus 0.61, V14 is minus 0.31, V16 would be minus 0.47, V17 would be 0.20 and V18 is 0.02. So now click on predict button. So here we can see the predictions in the blue color text, that is non-fraudulent transaction happened based on the machine learning for the given input. So it has classified it as non-fraudulent. Now click on home link. We will give another set of parameters now. So I have given another set of inputs. Now click on predict button. So here we can see the output, that is fraudulent transaction happened based on the machine learning for the given input. So it has classified it as fraudulent transaction. So similarly, we can give any number of inputs and get the classifications. Now click on logout. The conclusion here is the project has effectively tackled the critical challenge of credit card fraud detection in the digital era. As the world increasingly relies on digital transactions, the need for reliable fraud detection has become paramount. This project steps up to meet that need. Various data sampling and scaling techniques were deployed to refine the data set. This preparation ensures that the data is in optimal condition for machine learning models. It is akin to cleaning and organizing information before putting it to good use. By introducing Ensemble methods, the project significantly boosted the accuracy and robustness of the fraud detection system. Ensemble methods are like teamwork in machine learning, where multiple models collaborate to make more accurate predictions. The project didn't stop at basic Ensemble methods. It delved into advanced techniques. This exploration led to outstanding accuracy in fraud detection. This not only demonstrates the project's commitment to excellence but also highlights the potential for further improvements in the field. And a user-friendly front-end interface built with the Flask framework and incorporating user authentication was a crucial part of the project. This approach emphasizes the importance of accessibility and ease of use. It ensures that the system is not just accurate but also practical for users who can interact with it conveniently.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.